I'll be right back, folks. I'm just going to get another glass of water. Is you being a little bit camera shy? A little bit camera shy? There's a kitten. Ooh, hello, kitten. Say hello to all of the people. Say hello to all of the people on YouTube. That's Martin. He's the family cat. Yep. He's a half Bengal, half Maine Coon. So he's a big boy. So, someone from the stream that just finished wondered if I could go through question 2A from test 3, which, in the absence of them popping over here and also putting that question, I will do that, in the absence of any other, questions anybody might have about anything. Although I'm sure so many of you are scarred by this thing at this point. You know, maybe I'm just bringing back old trauma. Would we be able to go through 2C from the test as well? Well, if we do through 2A and 2C, we might as well do 2B and get the whole thing through, eh? Would that be a thing? I'm totally willing for that to be a thing. But we'll wait another 2 minutes for, everybody else to show up, The hecklers. Wait for the hecklers to show up. Don't want them to miss their chance. A funny thing happened to me today. Lately, out front of my house, the phone company has been excavating and installing new stuff, whatever they do, and they had dug up a lot of dirt. And by that I mean like actual literal soil. Except in my part of the world, soil is like really bad, just slightly under the surface. It's all like red clay, which is absolutely terrible. It's almost impossible to get at anything to grow in it, because if it's exposed to the air for very long, it basically turns into brick. Except you haven't formed it into bricks, it's just lumps of brick, solid rock like clay. It's awful. Anyway, so these I had dug up a certain amount of dirt of my own in my backyard, as we are installing a vegetable patch with improved and increased drainage. I installed a French drain underneath the vegetable patch so that we might actually be able to overcome some of the difficulties imposed by the fact that the soil is terrible. So anyway, I've got this great big pile of dirt on my driveway, and I go up to the guy one of the guys with a shovel, who is in the process of excavating that clay from it's on the city's property, but it's still in front of my house, And I said, hey, if you want to save yourselves some expense, I have this great big pile of dirt on my front lawn on my driveway that I would be more than happy to see you use for your thing that you're doing here. And I was told, in no uncertain terms, that the dirt that I had was not good enough, that they had to use special dirt because the city is going to be inspecting it to make sure that the proper dirt was used in the filling of these holes that they've created in the lawn. So, I am a homeowner scorned. I have had my dirt rejected by the city. It's not good enough for them. And not only that, just to rub it in my face, they dumped like 2 front loader scoops worth of their special soil right on that, like, not on my property, but again on the city property, like right in front of my front door. And it's like, no frickin' wonder nobody likes you people. Anyway, enough about my anecdotes. Let's get to it. So, question 2, Virus Wars. This was a, shall we say, something of a point of contention during the test. So, a popular subgenre of strategy game is the so-called Virus War format. I thought this was funny because we were having this whole pandemic thing, So, like, doing virus war seemed like a funny thing to do, but try to make light of the current terribleness. But anyway, so basically, the player is shown a field of cells, each with a virus count, and may attack other cells within a certain range. We are going to write some Python classes to implement a simple virus wars game. So, the position class. Everything within this game is going to require a position, so it makes sense to define it up front. Define a position class with the following fields: x, y, dx, dy, and speed. Speed cannot be negative. Raise a value error if the speed is provided as a negative number. Dx and dy are initialized to 0. X and y must be initialized during the initializer method. Define the following methods in addition to init. Move to, tick, and distance. Move to takes an x and a y coordinate and sets them to the values of dx and dy respectively. Tick simulates 1 second of simulation time. During a tick, if dx and dy are different than x and y, move x and y towards the values of dx and dy by the value of speed. If x or y are less than the speed distance away from dx or dy respectively, set the value of x or y to dx or dy. So, and distance takes self, calculates the Euclidean distance between self and other using Pythagorean theorem. So, we must, do we lose everything on J-Hub once the semester is over? You should make a backup. Make a backup. Yes. Notice you sent, okay. Daniel, you have been noticed. But perhaps you have not attracted the type of notice that you would want. So, in order to make the class, we have to make a class. Class, position, inherits from object, because almost everything does. Yes. Good. So, we define an init. It takes self, x, and y, although you should indicate them to be different from the attributes by giving them a slightly different name. Oh, speed must also be initialized. Speed 0. There we go. So self dot x is equal to xo. Self dot y is equal to yo. Self dot dx is equal to 0. Self dot dy is equal to 0. Self dot speed is equal to speed. Speep. There we go. Def. So that's init, more or less cut. Oh wait, nope. Sorry. I almost forgot. The this bit, we have to raise a value error if we are given a negative number. So, if speed 0 is less than 0, then we raise a value error. Otherwise, we just continue on as normal. Yeah. Oh, goodness. You might be able to log into the Jupyter Hub with like an SSH client or something, which might make it a little easier to download all of the stuff from it, but in general, I forget how you do that. You could always, I think you can download a folder, so if you move everything into a folder, then download the folder, then you get everything. I don't know, that's the type of thing I usually ask a TA to do. Anyway, so we got some methods. I'm just gonna, well, Alright, I'll just keep scrolling. So, we have a move to. This is a command. It takes self and an x and y, so we'll call it x0 and y0 again, just so as not to confuse it. Although it's technically no name interference. So, I'll answer your question in just a moment. Haha, Python go brr. So, all that does is sets self.dx to x0 and self.dy to y0. Okay, so question, what is a passing grade? 50%. A passing grade is 50%. And do we need to pass the exam to pass the course? No. No. There's no restriction on this course that you have to pass the exam to pass the course. I don't know. Some people do that. I can understand it in certain contexts, but I don't know. Especially given the current circumstances. Even if I had put that into the syllabus at the beginning of the semester and said you must pass the exam to pass the course, under the current circumstances with the move to online and all of the fidgemy flops that have ensued as a result of that, I would probably lift that restriction anyway. So, no, you don't need to pass the exam to pass the course. Anyway, so let's do the other easy one. Def, distance, takes self and other. There we go. We want to return self dot x squared, no, it would be other, we want the distance, other dot x minus self dot x, blah blah blah, squared, plus, no, there we go, other dot y minus self dot y squared, and we want to take the square root of that entire thing to the exponent 0.5. Nice and simple. Next, we wish to do this tick thing. So, def tick takes self and no other arguments, I believe. Yes. So, if self dot y, or x, let's do x. Let's do all the x and then do all the y. Self dot x minus, sorry, I had a hair in my mouth or something. Blech. Super gross. Coronavirus. It is still there. Wow. Anyway, what was I thinking about? Yes. So what we want to do is we want to see if the difference between the dx that we want to get to and the x that we currently are at is less than the speed. So self.x minus self.dx, is that greater than or less than speed? Of course, with that you have to take the absolute value. So I believe this is import math, something like that. Maybe it's got a small m, I don't know. At any rate, we have to see if that's less than speed. There we go. Math. self.abs. This will probably not work the first time. That's fine. I'll just look up the syntax for performing that particular operation at that time. So, if that is the case, then we set self.x to self.dx. And of course, this is all predicated on the idea that self.x is not equal to self.dx. And if it is, then we want to move in the direction of dx. So, if self.x is greater than self.dx, then we are going to take self.x minus equals speed. Otherwise, self.x plus equals speed. There you go. That should be everything we need for the x value of the tick function. The y value functions entirely in the same manner. So we can simply replace all of the x's in this particular piece of code for y, and everything seems like it should work out. CoronaBunker. And yes, no module math. Oh, I predicted it. How about that? Okay, sure, but ta-perm. Yes, math is not defined because it's lowercase, and maybe abs doesn't exist either. Attribute error. At this point, one has to give in and say, what is it? Python absolute value. How do I do that again? Is it just that? Do I even have to import math? I don't even have to import math. There you go, folks. You don't even have to import math. Gosh darn it. Absolute value. Absolute value. Bing, bang, boom. Speed is not defined. Oh, yeah, of course. Because, you know, I forgot to do self.speed everywhere. It really is true that find and replace is like the programmer's best friend. Did I really not do the one statement in which that was? Yeah, I didn't. Aha! There we go. So. Thank you. So, anyway, and this one. There we go. So there we go. That is the position class. If there are any questions about that, please upload them to the comments. Or the chat, rather than the comments. It's like the running commentary. Alright, so now for the much maligned question 2b. Class cell, I can remember that much, inherits a position. So, what do we have here? We've got color, viruses, defense max, defense range, attack range, and mood. There we go. So, So, we define the initialization. It's kind of hard when, like, do you mind if I'm just going to set the zoom to a slightly lower zoom, if that's okay, so that I can read more of this at the same time. So, we know that we need the following attributes. Self dot, and we know we're going to take self. Self dot color in Canadian spelling. Self dot viruses. Self dot defense. Oh, no. Pardon me. Sorry if I broke anybody's earbuds. That was involuntary. Coronavirus. Self dot max defense. Attack range. Self dot attack range. And self dot mood. So, now we can start picking these apart. So we are taking X, Y, color, and attack range. So X, a Y, a color, and an attack range. Sure. So these ones obviously will get initialized to their corresponding values. Attack range would be A range. And after all of this, we are going to want to position dot init with the self. I think you put self in there. We'll find out when we compile it anyway. X, Y, and that other thing, which was speed. Speed, of course, depends on the mood, as we'll see. So, happy cells have a speed of 0.1, angry 0.2, stoic 0.005, busy, and 0. Speed should be initialized accordingly. However, mood is always initialized to happy, so the speed is always initialized to 0.1 as a result. So that's going to be a 0.1. And mood is always initialized to happy. So, because so this max defense initializes to 10, and so does defense. So we can just pop those guys in there. With respect to viruses, indicates the number of viruses contained within cell, initializes to 0 for cells with color none, initializes to 5 for all other colors. So, if color equals none, viruses equals, what was it? 0? Was it 0? Yes. Viruses equals 0. Else, self.viruses equals 5. There we go. So, a few people, I'm not actually sure how many people did this, but the number of the people who did it were fairly vocal. They put a thing in here where if you tried to initialize it with colors other than red or blue, there was a misinterpretation of the question here. Valid values include things like red and blue. They interpreted this to mean that the only valid values are red and blue. This is not the case, and they decided that that you should raise an exception when this is attempted, when you attempt to initialize it with anything other than red and blue, which of course is problematic because even like that excludes none as well. Some people included none in that, but that would cause your initialization function to fail anytime it was you tried to run it on anything that wasn't red or blue, which a few of the test cases had colors that were not red or blue, so some people lost some marks over that. But that's that's because their code was pretty damn fragile. That's what that makes your code, is fragile. So we want to define a few methods on top of that. So we want to define a tick method. We want to define a change mood. We want to define a attack. And we want to define an EQ. This is good. This is good. So let's do the easy one first. Two cells are the same if they have the same coordinates, have the same number of viruses, defense, value, and mood. So this is reasonably easy. Self and other. So return this and this and this and this and this. So we have 5 individual conditions to be checked for here. Self.x equals other.x. Again, copy paste is your best friend, except if it's from somebody else's test. Copying, pasting your own text is fine. Self.y equals other.y. Self.viruses equals other.viruses. Self.defense equal to other.defense. And self.mood is equal to other.mood. There you go. So that's the EQ function accomplished. So, tick. Let's do tick next. Tick's no arguments besides self. Determines the behavior of the cell population according to the cell's mood. Happy cells produce an additional 3 viruses each tick. Busy cells produce 8 additional viruses. Stoic, 6. Angry cells, 6. So we can work with that. So for tick, if mood is equal to happy, elif mood is equal to what are the other ones? Busy, stoic, and angry. Ta 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 ta. Then viruses self dot viruses plus equals 3. It's 3, 8, 6, and 6. 3, 8, 6, and 6. And that is the viruses taken care of. So the defense parameter also moves towards the value of max defense by 1 every tick unless it is equal to max defense. Don't forget to call tick for the inherited class. So if defense is greater than max defense, defense minus equals 1. Self.defense. Oh my god. The whole self dot thing is one of the reasons that a lot of people don't like the way that Python does classes. So self dot, if defense is less than the max defense, then self dot defense plus equals 1. And that's it, because you don't have to do the else case, because the else case doesn't actually do anything. And then we have position dot tick self. There we go. Good. Next, change mood. Takes the argument new mood. Creates value error if the new mood is not in the list of the moods available above, excluding happy. So if it's happy, it also trips an error. Costs 20 population for a cell to change mood. If there are insufficient viruses, create a custom viruses insufficient exception. Otherwise, subtract 20 from the virus population and change the mood to the specified value. If that value is stoic, change max defense to 30. If it's angry or busy, change max defense to 5. Remember to adjust the cell's speed for the new mood. So, this is a lot of stuff. So first of all, we're taking self and a new mood. How is it possible for defense to be greater than max defense? Doesn't that defeat the point of max defense? Well, it's interesting because some virus moods have higher max defenses than others. So, for example, if you were a stoic virus, or a stoic cell, which has the highest max defense of 30, and then you changed to any of the other types, like, for example, angry. If you go from stoic to angry, your max defense goes from 30 to 5, and the idea would be that your defense value would tick back down to 5 over time. There would be a time delay. So, because notice, change mood, there's nothing specified in this description of change mood that says that the defense value is actually changed with all of this. So anyway, if new mood is not in stoic, busy, or angry, raise a, what was it, a type error, value error? Value error. So there we go. Next, we have to check if you have sufficient viruses. So if if self.viruses is less than 20, raise viruses insufficient error, which we will have to create. So class viruses insufficient inherits exception. There you go. Else self.viruses minus equals 20. That's the cost being paid. So then we have to change self.mood to new mood. If self.mood, or you know what we can do, new mood. Because who wants to write self dot all the time? Is stoic. Self dot max defense is equal to 30. Elif new mood is equal to busy. Elif new mood is equal to angry, which this question made many people, etc. Just using my brain meats. I think I remember that was 5 and 5. And then we also had to modify speed. So, self dot speed is equal to angry is 0.2, stoic is 0.05, and busy is 0. So angry, stoic is 0.05. Busy is 0, and angry is 0.2. There we go. So that is change mood, more or less accomplished. Just checking. Bing, bang, boom. Okay. So now we do the attack. And I'm just going to move this to the top so I don't have to scroll quite so far. So, attack takes self and other. If position dot distance self and other is greater than self dot attack range, raise out of range exception, which we will have to create. Out of rage. That's another one that a lot of people would have had after this test. Else. So, the cell attacks with its whole population. This is the base attack value. So base attack value is self.viruses. The actual attack value is the base attack value minus the other cell's defense value. So actual attack value is equal to base attack value minus other.defense. If the defense value is greater than the base attack value, reduce the defense by the base attack value. So if So if the base attack value is greater than other.defense, then we reduce that. Other.defense is, well, there are a number of ways to do this actually, but minus equals the base attack value. Then if other.defense is less than 0, i.e. if it goes into the negative, it can't, so it becomes 0. There we go. So, there you go. So, the other dot attack, other dot defense, you want to calculate. Basically, the idea is the incoming attack value eats into the other's defense first. The actual attack value is the attack value against the defending cell's population. And the defenses are used up in the defense against the base attack value. So, if the actual attack value is greater than the other cell's population, the attack succeeds. The cell's color is changed to that of the attacking cell. The cell's population becomes the difference between the actual attack value and the defending population. If the attack is unsuccessful, the defending population is reduced by the actual attack value. If the defending population and the attack value are the same, the cell returns to none. In any event, the population of the attacking cell is reduced to 0. So, yes. So that'll be the last statement. Self.viruses equals 0. So, if the base attack value is greater than other.defense, this is good. This is continuing on with the same thing. So in the case where the other.defense is less than 0, that would mean that the base attack is greater than the defense, which means that you will inflict some casualties on the other's population. So other.viruses is equal to actual attack, or minus equals actual attack value. If other.viruses is less than 0, i.e. if it goes negative, then other.color equals this self.color, and other.viruses multiply equals -1, i.e. all you have to do to calculate how many are left over is you take the, if the difference goes negative, then you reverse it. Our other caveat is that if other.viruses equals 0, then other.color equals 0. Or none. What am I saying? There we go. There you go. So there you go. That's that question. 2B. Ta-da! So let's see how many syntax errors we have. Line 32. There you go. Okay. Now on to we'll finish things off with virus game class, virus game. There we go. Ta-da! So unlike the difference with virus game is that it is not actually inheriting the cell class. It contains a list of cells, but it doesn't actually inherit cell. So def init takes a parameter n, generates a number of cells between positions. One of these cells, it doesn't matter which, must be initialized as red cell, and the other must be blue cells. All cells have an attack range of 0.3. So, there we go. We have a number of cells that we need to generate, and basically we need to import random at this point. And there are a number of random functions which are possible. A lot of people were using uniform. Notice I'm looking this up. Boop, boop, boop. So, if we are generating something, if we use random.random, that gets us a random floating point between 0 and 1. Boom. So, we can say random.random times 20 minus 10, and that will be a random floating point value between -10 and +10. So, we want to initiate self.cells as an empty list. You can do it all in, no. Self.cells dot append cell, which will take this for X, this for Y. It will be a red cell, and it will have an attack range of 3. And we shall do this again. It seems I might have a mismatch on my parentheses. There we go. This one will be a blue cell. So we then while n is, we'll say n minus equals 2, while n is greater than 0, and n will be decremented. There we go. So there you go. That's how you can initialize the cells list here. It turned out that this ended up being fairly open-ended. The question doesn't really say what to do with all of the cells that are not red and blue. I can tell you that like the kind of solution that I had in my head is that they would be all none. Certainly, like the question has been structured in that manner. However, it was, it was open to interpretation, so nobody lost marks on how they interpreted that particular thing. So we got to define a couple more. Define check victory self. If all cells have the same color, then return that color as a string. Otherwise, return not yet. So this is fairly straightforward. So test is equal to cell self dot cells 0 dot color for C in self dot cells if C equals or does not equal self dot, or pardon me, if test does not equal C dot color, then return not yet. And if you manage to get through that loop, return test. There you go. Check victory. Define. Next one. Let's do tick because it's easy. Tick. Take self. Again, just another for loop for C in self dot cells. C dot tick. There you go. Some people used super, which also worked, although it broke some of the test cases. And then we have def action, which was the tricky one. So takes self, takes position 1, position 2. So the algorithm always goes with the first cell it finds that is within a radius of 1 for both positions. If there is a cell at the first position and the second position, the cell at the first position attacks the cell at the second position. If the second position is not within range of any cell, the first cell is commanded to move to the second position. If the second position is within range of the first cell, change the mood of that cell to busy, and be sure to handle any exceptions. If the first position is not within range of a cell, the method does nothing, regardless of the state of the second cell. So, what you have to do is you have to write an algorithm which searches for the first for a cell that matches a position. It might even be useful to define a method for this. So find cell at position, self and position. So for C in self dot cells, if position dot distance between C and P is less than or equal to 1, return that cell. Else return, -1 or something. Some sort of this didn't work sort of value. So cell 1 equals virus game dot find cell at position self and 0.1 and self C2 and 0.2. Then if C1 is equal to -1, i.e. it didn't find anything, then do nothing. In other cases, if C1 is equal to C2, then C1 dot change mood to, what was it? Busy. Handle any exceptions. So try to change the mood to busy. Accept, pass. Else C2 is equal to -1, i.e. C2 doesn't exist, then C1 dot what was it? Move to P dot x1 P dot X and P dot Y. There we go. Da-da-da. Or P2. There we go. Else, which is the case where everything else. C1 dot attack C2. Okay, I think that's it. Look at me using capitals again. Oh, warp. I forgot to include these guys. Whoopsie daisy. And there you go. Oh, we got an attribute error. Oh, right. Right, I can't compare it to -1 here because how do you compare to -1? I suppose you could raise a value error or something. So that sort of restructures everything. Hey, there we go. And it worked. Fantastic. Anyway, so yeah, that's Virus Game. I kind of took up the whole thing. So yeah, there you go. Any other questions? We're kind of running short on time at the moment. If there are no other questions, then I'm going to close off the stream here. Also, one more note about the whole, if you want your stuff off of Jupyter, take a backup, because probably not too long after the exam, we're going to have to wipe the server so that we can reset it for the spring offering of this course. So save the data. The data is going to go away sooner than you think. We will also keep backups of the data. We will also keep backups of the data, so like if you somehow don't get everything that you need, we will have backup copies that you can come bug us for afterwards. Kind of confused on tick. All right, for 2C, let's see here. Okay, so the idea for tick is that all you really want to do is like filter down the function call to all of the things that are tickable. So each cell in the virus game needs to have its tick method invoked when tick is invoked for the whole virus game. So basically all you're doing is you're going through every cell in self.cells and calling tick. Hopefully that that helps. Kane72 says, "See you, Mr. Moore." See you, Kane72. Have much fun. Have much laughs and enjoyment. Don't fall down a staircase. It's a bad time. Good luck on your exams, everybody. Not just mine, but your other exams too. And with respect to the current ongoing situation, just hang in there, folks. It's terrible, but it's temporary. We're going to beat this thing. We're going to grind it into the dust. I really liked the recent XKCD cartoon that came out, because it sort of flips the perspective. It's like, we're not stuck inside. The virus is stuck in here with us, and our immune systems are the scariest thing in the world to a virus. So, yeah. Keep it together, folks. Keep it real. Do some baking. There's been a lot of baking going on. It's very therapeutic. But anyway, take her easy, folks. Keep it real.